All right, lesson 2.3, graphing linear functions. Should be a lot of review from Algebra 1, slopes and intercepts and a little bit of standard form in there, so we'll mix a few things in you might need to brush up on. But here we go. So first thing is we need to determine if a function is linear from a table. So we're looking at the table, and what we want to be able to do here is we need to see what x and y are changing by. Remember, f of x, you can also just think of this as y. So let's look at our change in x, and I'm going to represent, I'm going to just kind of write it up here, but change in x is just going to be written as delta x, just that little triangle symbol. It just means how much it's going up or down or changing by. It's delta. All right, so when we look at x, it looks like it's going up by 2, up by 2, up by 2. All right, so change in x is going up by 2. Change in y is going up by 3, going up by 3, and going up by 3. So when you think about slope, you know, if you remember back in the day, the slope equation, you know, is rise. Some people say rise over run, you know, or some people say y2 minus y1, x2 minus x1. All right, all of those are finding the difference in the y's and the difference in the x's. So slope is really just the change in y over the change in x. It's that ratio of vertical change compared to horizontal change. So looking at my chart here, this is constant change. So this is a constant rate of change. So it is linear, all right? You know that something is going to be linear if you have a constant rate of change. Now, that rate of change, another fancy word for that, is just slope. All right? And let's actually calculate the slope. So if I do the change in y over the change in x, and the table's written kind of backwards from this, but the change in y is 3, and the change in x is 2. So this has a slope of 3 over 2, or 1/2, meaning that we're going up 3, right 2 as we move across the table. So in your homework, I actually asked for that rate of change or that slope, and you can get it from the table. It would also help us write the equation. You know, next chapter we're going to write the equation, and I know this equation is y equals slope, and then I also can see the y-intercept here at x equals 0. It's -1. So I actually could build an equation from that table, but we'll get into that later. All right, next one, move a little quicker. When I look at my x is dropping by 2, so going down by 2. So when I do change in y over change in x for slope, change in x is a -2. Well, change in y, looks like we drop 2. Ooh, but then we drop 4. And then we drop 8. So that is not a constant change. So that means this is not linear. All right, not linear. All right, moving on down, let's get into some graphing. Graphing lines using a slope and a point. And I'm just kind of putting these graphs on here where you put your own axes. You just kind of have to look at the points. So we're going through 1, 1. So I'm just going to go ahead and label this one like normal. Just kind of put my grid on here, my x, my y. Well, we're going through the point 1, 1, so I'm going to start here. And then from that point, my slope is positive 2/3. So first of all, positive slope means you're going to go up and to the right. All right. A negative slope, I would be going down and to the right. But a slope of 2/3 looks like I'm rising 2 and I'm running 3. So up 2, right 3, up 2, right 3. And then we could back it on up and we could go down the other way. And then you always want to connect these out and actually put some arrows on there, and there's a nice line. Number 4, slope is -2 and passes through -1, 3. So I guess I'll just put my normal axes right here where we normally would. Some questions are only first quadrant, so I like to leave it open to you. Little x, little y. I pass through -1, 3, so go left 1, up 3. So there's where I go through. Now a slope of -2. Well, I know I'm going to be coming down and to the right. All right. Well, when it's not a fraction, what you want to do is you just want to put a 1 under it. So that means we're going to go down 2, 1 to the right. So down 2, 1 to the right, 1 to the right, 1 to the right. And you can back it on up and go the other way. There we go. There's our equation. There's our line, I guess I should say. All right, example 5, graphing lines using the x and the y intercepts. Well, sometimes, if you recall, this is what's referred to as standard form, all right? As opposed to, we're going to do slope-intercept here in a second. But standard form, you know when you have x and y on the same side. You have x and y on one side, and then you have just your number over on the other. Well, normally if I were to say, hey, graph this, a lot of kids would rearrange it, and you would move it into slope-intercept form. That's a lot more work. You know, you could do that. You could say, well, you know, 2x minus 3y equals 12. And you move the 2x to the other side, which would make it negative. Then you divide everybody by -3. Divide by -3. And then you would end up with y equals a negative divided by a negative is a positive. And then 12 divided by -3 is a subtract 4. And then you would graph that line. All right, that's how you normally do it. A lot of times, though, when it's in standard form, you could find the intercepts. So remember what the x and the y intercept are. The x and the y intercept are just basically where you cross the x and the y axis. And if you think about it from a table perspective, this is my favorite way to kind of think of it, is you just put a 0 and a 0. You find out y when x is 0, you find out x when y is 0. That's probably the most straightforward way. So instead of going through all this, I'm just going to make a little table out of this. So let's put 0 in for x. So that wipes out this first part. And I just end up with -3y equals 12. And divide both sides by -3. And you get 1 point. Then you go back and you repeat the process. And you put 0 in for y, which wipes this term out. And you get 2x equals 12, which would be x equals 6. So now I have 2 points. I'm just going to put the standard kind of viewing window on there. X, Y. And we're going to graph those 2 spots. We have 0, -4, and 6, 0. And there we go. So sometimes it's really easy to graph using the intercepts. Just set up your little XY table. Always just kind of set that thing up and start it, you know, at 0, 0. It works really, really good when both of your numbers, your coefficients, go evenly into the variable over on, or the number on the side. So notice 2 went into 12 evenly, 3 went into 12 evenly. When that happens, you get nice clean points. If I were to do one like 5x minus 7y equals 12, that's going to kind of suck, because when you do your little table and you put 0 in for x, you're going to get y equals, what would that be, -12/7. And then if you were to do 0 for y, you would get 12/5. And those points are a little bit tougher to graph. So a lot of times if I kind of peek at that number and I'm like, well, if they don't go in there evenly, I'm going to just move things around and get it in slope-intercept form. But if they go in there really nice, it can be a really fast problem. All right, next one, graph functions in slope-intercept form. So recall from either geometry or algebra, slope-intercept form is y equals mx plus b, where there's your slope and the back number is the y-intercept. So looking at number 6, this one's really not in slope-intercept form. So I'm going to subtract this 3x from both sides, and it's going to go away, and I get y equals negative 3x plus 5. And I think I want to, let me move this down just a little bit so we can get the graph on here. I have to shrink it just a tad. I want to be able to see the problem, and there we go. All right, so I moved the 3x over, I get y equals negative 3x plus 5. So remember, when you graph using slope-intercept form, you always want to start here. So I want to start at the y-intercept. So we're crossing at a positive 5. I have a negative slope, so I think the standard window here would be fine. So we start at a y-intercept, which is on the y-axis right here at 5. And then negative 3, well, that's kind of like negative 3 over 1. We're going to go down 3, right 1, down 3, right 1, down 3, right 1. And there we go. Slope-intercept is really nice for graphing. All right, on this next one, well, it's almost in slope-intercept form, but I have to get y by itself. So an easy way to do this would be 2 ways. One is I could multiply by the reciprocal. So if you want to go that route, I could times both sides by 3 over 2. And on the left, multiplying by the reciprocal just gives me 1. But then I would have to multiply by 3 over 2 here, which that's okay, that's fine. You also could do what we did a lesson or two ago, and I could just multiply through by the denominator. It ends up being the same thing. You get 2y equals 3x minus 9. Divide by 2, divide by 2, divide by 2. And you get 3 halves x minus 9 halves. So it would have been the exact same thing had you had distributed. So really, 6 1/2 dozen the other. I need to cross at a negative 4 1/2. So I think, again, we're getting lucky here. A lot of standard windows. Fine. I got to ballpark this kind of. So at negative 9 halves, well, that's negative 4.5. So cross roughly right about there. And then from that point, I need to go up 3 over 2. So up 3 is going to be a tad bit tricky. I got to go up 1, up 2, and up 3. So there's up 3, and then over 2. It's going to put me right about in here. Then up 3 over 2, and up 3 over 2. Right through there. Go ahead and slap a line on it. And we are good to go. All right, also before I finish here, it says graph the line x equals negative 3 above, and then the other one says graph the line y equals 1 above. So you can just add it to your grid. I'm going to go ahead and erase what I had just so it doesn't mess with us at all. But remember, whenever it's x equals a number, this is a vertical line. It's a vertical line because remember, this just means that if you made a table of values, x is always going to be negative 3 no matter what. And y can be anything that it wants. So when I put that on a grid, it basically looks like this. Every single order pair right here is going to have a coordinate of negative 3 for the x-axis. I don't know how you can remember that. I know at one point I kind of used to teach that, x equals a number was vertical, and it kind of made me think of Xavier. It's a college. They used to be pretty decent at basketball back in the day, I guess. But you could do it that way, or just memorize it. Conversely, the y equals a number. These are horizontal. So these are your side-by-side lines. you go up to a value of y equals -1, and you draw a line going horizontally. All of those pairs, if we were to make a table, every single one of them would have a height of -1. X could be anything. So those are kind of the freak cases you got to be careful of. All right, hopefully that's a quick little review and get you ready to do the 2-3 practice. See you.